Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
So today we are going to get started with Kubeflow. So we have two sessions on the Kubeflow. One which is like understanding the Kubeflow. What is Kubeflow? Why do we need it? How it works? Architectures? What are the features? And some of the installations, instructions, discussions, and all kind of things. And then followed by we'll have one demo on the Kubeflow. So let's get started. So demo we'll have in the second session. Today we'll go through all the discussions part of it. So
Okay.
yeah, as part of this discussion, I will cover the Kubeflow overview, some of the brief intro of Kubernetes, which I'll skip it. But you need to know operator, that is important in Kubernetes, and some of the installations activities we'll discuss, though it required a little bit of time offline also, like creating clusters and all. You'll keep it ready, keep it ready offline because it will require multiple hours and all. And then we'll discuss about um,
Okay.
Jupyter, yeah, Jupyter notebooks, the feature which is a part of the Kubeflow, though you can use it separately also. We can also will see the TensorFlow, PyTorch. We'll discuss about the cafe jobs, some hyperparameters and Katib jobs and all, and serving and certain questions. So whatever the component you see, like notebooks, pipelines, TensorFlow, PyTorch, and many more, these all are the separate component actually. But everything you can find it on Kubeflow, and that is what we call it a Kubeflow is a place where you will get all the tool set for the MLOps. Okay, so if you are a data scientist or data science engineer or something, or data analytics engineer, then most of the time you are working on the machine learnings, and then machine learnings for that you will use Kubeflow. So yeah, some of the things which we know, which has become a truth nowadays, like everything nowadays we run on the containers, you know that. And then also there is one more truth we have is like the orchestrations, scaling the containers, we use Kubernetes, and that you know that, right? So these are the some of the things.
Yes.
So Kubeflow is about to make deployment in ML environment on Kubernetes. I'll put it in this way. Let's say if you do not have a Kubeflow, okay, then how do you manage the machine learning environment? If you remember, in a machine learning environment, you had a data. Yesterday we discussed, right? We had a data, and then we had algorithms, hell lot of algorithms, and then we had a model. We train the model, and we keep checking validate the model whether it's working or not. Keep testing that, and then we deployed the model to the environment, and then followed by we do the monitoring. So that is something which we do in the machine learning environment, right? And for that, we have we had a hell lot of tools earlier. So many tools. Integration was, very cumbersome. Um Deployment was very challenging. Lots of failure, lots of delays. Actually, CI/CD has brought what? CI/CD has brought the reduction in time of the releases. So something similar, Kubeflow is helping us in terms of deploying the ML environment on a Kubernetes in a very simple way. That's all. That way, if someone will ask you what is a Kubeflow, so you can say Kubeflow Kubeflow will help us to deploy the ML environment in Kubernetes in a simple way. So yeah, if you want to understand that why we need a Kubeflow, so again you have to go into the the life cycle of how the data scientists are working in order to train the model, right? And then you will realize lots of challenges they are facing, especially the data scientists. They are very good in mathematics, they are very good in algorithms, but they are worse in IT areas like compute, storage, infrastructure, orchestrations, and all. And but you need a infrastructure, right? In order to train the model, you need lots of compute, lots of uh, storage, right? You need a lots of place where you can keep all the algorithm. You need a place where you can keep the models, and versioning and many other features you need it, right? You need a place where you can deploy the code. So all these things you need it, and they're very bad in it, data scientists. So yeah, the that was a challenge which we had with the data scientist. Data scientists are the world's IT customer. Diversified tooling and framework important to support many choices. Must experiment constantly with a new paradigm and engine must make experimentation and tool deployment easier. So some of the challenges we had with the data scientists, and that is what we are trying to solve. Now, Kubernetes has made our lots of work easier. Now, what is Kubernetes and all these things? You know that. We have had a sessions on that, and probably you know that. So Kubernetes has made this our journey very easy. Let's say if you want to run any application, you can run in a container in Kubernetes. If you want to scale some application, you can run in Kubernetes. So now what we are thinking, like, can not the data scientists also run their whole environment, learning environment, training model in the Kubernetes? How can we do that? So what is the options we have it? And that is where the Kubeflow is coming into the picture. So if you see that here, each data scientist will want to run their own favorite training framework. Yes, let's say you are you are liking PyTorch. That's a training framework. PyTorch is having collections of algorithms. Remember that I told you thousands of algorithms are there. So PyTorch is
Yes,
basically
yes.
one framework. Yeah. So PyTorch is basically a framework where you have thousands of algorithms to train certain models. But TensorFlow is also popular. Maybe someone else likes something else also. So there are a hell lot of framework available in the ML, and almost I see like every 6 month one is being introduced nowadays. So how do you, I mean, let's say you have a 10 data scientists in your team, and each one of these people wants to run in a different framework. How do you support? If you're on a physical server or virtual machine, it's very difficult to immediately migrate from one to another. But Kubernetes, you know that very well. You can immediately destroy a whole infrastructure. You can create whole infrastructure. You can run some code for certain time. You can scale it, scale down. A lot of features we have on the Kubernetes, right? And services we have in Kubernetes. um, Persistent storage we have in Kubernetes. So lots of features we have. So that is what we are trying to do. Data scientists should have one platform where they can use the Kubernetes in an easy way. At the same time, they should have all the tools at one place. So that is the region for Kubeflow. So what is a Kubeflow? In short, Kubeflow is basically you can say it's a collections of multiple tools which will facilitate the ML and AI operations. That means I'll put it in a more simple way. It is just a website. I mean, you can use through command line also, by the way, but just to make it simpler, it's a website where using that you can do the machine learnings and AI practices. Simple. So a repository for ML and AI tools, and this repository is getting more curated and lots of release which is coming as you go on. So basically, Kubeflow, you can do the whole ML life cycle. I'll put it in this way. Are you aware of Azure DevOps? That's the one platform.
Azure, I know Azure
Okay,
DevOps.
okay, no problem. Are you aware of Jenkins?
Yes, yes, yes.
Yeah.
Jenkins, I'm aware.
So Jenkins, you have all the features, all the pipeline you can create, right? For the all the life cycle for software development. You can integrate with SonarQube, Jira, Git, GitHub, GitLab, Artifactory, Nexus, a lot of tools you can integrate, right? Correct now? So
Yes,
something
yes,
like that. So something like a Kubeflow. So Kubeflow for the see for the there's one branch called software development, and there is one another branch which you call it a machine learning, which we discussed last day. So for the machine learnings, you need a hell lot of tools for different use cases, different problem, and for each of these use cases, that tools you need it, which you can find in the Kubeflow. Okay, so now you'll ask, okay, what kind of tools we need for machine learnings? So I think this image is a very good one, which you got it. So you see that hell lot of tools you need it for different reasons. See that one phase which you call it a system one, then phase 2 system 2, phase 3, phase 4, phase 5, right? Phase 6. So all these phases you can say. So in the phase 1, what you are doing, you need a data ingestion. There's one tool for it. Then you need another tool, data analysis. There's another tool for it. Then there is another tool for data transformation. Then there is another tool for data validation. Then there is another tool for data splitting, and then building a model validation, training at scale, rollout, serving. Serving means deployment to the production, and then monitoring and logging after the production. So these are the things you do where these are the each of these are ML stage. If you do independently, these are the tools you have to deploy. For each block, you see there is one tool for it. And now this will become a very complicated, right? Because once you create a flow, then let's say pipeline, then you have a challenges like integrating multiple tools. So what about one tool for it? The tool. So how can you do all these things in the laptop? Okay, how can you do in the environment where you are training the model? How can you run in the cloud for the production, right? Because you can't train in a laptop. Why? Because laptop has a limited resources. Correct now? For the training, there is a pre-prod environment. You train the model and then make it live in the cloud. Correct now?
yes,
So what do you need? You need a model, you need a UX, you need a tooling, ML toolings,
yes,
tools, framework, you need a storage, you need a runtime in CPU, RAM and all. You need a many drivers, operating system and hardware. And you need in your laptop training environment and cloud. So you can say three environment. Laptop where we just write algorithm to test the few models, few algorithms, few cases, and then we run at the large level in the training environment, and then make it live in the cloud. So how can we do that? How can we do that? So broadly, if you put it up, everything, okay, so you need lots of feature which includes logging, monitoring, data versioning, experiment tracking, and all. So you need that. So what has been done? What has been done? The engineers has come up with the one tool which is called Kubeflow, which is open source, and they have brought all this platform at one place. So let's say you need a data exploration and visualizations. Data exploration and visualizations means this ingestion, analysis, transformation, validation, all these things you need it, right? So for that you can use a Jupyter notebooks. Okay, and I think some maybe you know that Jupyter
yes,
notebook we
yes,
use for the this one. So we have a notebook. That means that tool you will find in the Kubeflow. Then you need a some sort of pipeline, something like we integrate one to another, right? So you need a pipeline, right? So that you have it. Then you need a lots of framework for model training, and that you have it at one place, all the framework whichever you like. And then you want to make it live for the end user to use it, which is called serving. And then after that you have to monitor, let's say some monitoring tool. Here in this image it's a Prometheus, but nowadays we have a tens of tools available for that. So these are the phase which you need it in order to manage the machine learning lifecycle, and that that what you get it at a Kubeflow. So Kubeflow is a one of the platform you can say, or you can say one of the platform where you can get the entire ML machine learnings tool sets, which can be used for you know doing a lot of things. So exploration
Okay.
phase, training phase, deployment phase, and production phase. You need a hell lot of tools, and all these tools you will get it at Kubeflow. Okay, some of them popular are like Jupyter Notebook, Katib, PyTorch, TensorFlow, HTO for monitoring Prometheus and all. So many tools. Again, apart from that, again, I just said these are the I mean these are the growing domain actually. So a lot of changes you might see in an upcoming few months or few years actually, because just we have started talking about all this thing, right? So yes, so when you are using the Kubeflow, you must remember it's all about the platform called Kubernetes, and then you have lots of toolings and frame applications like Pipeline, KFServing, Katib, and Jupyter Notebook, and TensorFlow, and many more. Okay, so these are the things you will get it. So in terms of notebook, you will get two options. Again, it's this slide is not up to date, so you have to check few more plugins might be there. So Jupyter Hub, Jupyter Notebook, the ML operators like framework for training the model. TensorFlow is the most popular one. PyTorch, Cafe, ML, and few more, and so many others will be there. In terms of serving, when I say serving, that means what? So I'll put it in this way. Serving, you should take it very lightly. Serving means making it the model available for the end user. I'll simplify a more better way. Serving means for creating a kind of DNS and load balancer sort of it. Okay, so there is one tool which is empowered, which is called KFServing. Okay, that is powered by
Okay.
Knative. Knative.
Okay.
Okay,
Get it.
Knative is one of the serving the Knative. So Knative is again Kubernetes tools. So for the serving, typically we use the Istio with the Knative, which you call it a Kubeflow. Kubeflow serving is inbuilt because TensorFlow framework is also there for training the model. Seldon is there, and few more are there. Many miscellaneous tools you have. Ambassador again for the service mesh. Katib container for the uh, provision the parameters and all. Many options are there. Argo CD, if you know, for the CD and Minio, MySQL, and few more actually. Okay, UI, I'll show you the glimpse of it. Central dashboard and tensor board also you can use it. But today, I mean, our session we'll use the Kubeflow central dashboard. But there's one session which we have TensorFlow separate one. There I'll show you the tensor board. So tensor board is also growing a lot. So okay. So this is something which we have. So now what is the difference between VMs and container? I'm not talking all this right now because we all understand that historically we've been running in the physical server, then VM, then containers, and then we got container got isolated through images, and then all this thing we know that, and then we started orchestrating using Kubernetes on the pod, and pod isolations also we understand more or less. So yeah, these are the things. So yeah, so Kubeflow workload are easily deployed into Kubernetes namespace for security and compliance with resource quotas. So now if you see that here, um, here if you see that there's a platform and then you want to deploy notebooks, uh, one we call it tenant A, and that is in one namespace, then second namespace like that. So each of these features will be deployed in the separate namespace. So that way it will be isolated. Now the question is, I'm just skipping the Kubernetes related discussions. So how do we manage the persistent storage in the Kubernetes? We know that PVPBCs and all, so that is there. So now Kubeflow aware storage. So the Hadoop world has been focused on data locality and SDFS. Hadoop is very important tool for data scientists. You know that. So Kubeflow world is different. Uses tons of POSIX and S3 objects, storage and APIs. That means for storage, you want to use Kubeflow, and for that you need to use a object storage APIs. Both are incredibly important. They need to be integrated into Kubernetes. We should not just do the NFS and call it data. So if our workload are going to move across the network, we need to think about how to move data across architectural and geographical divide. And then copying data really sucks. MMR plugins and all kind of things can be used. So read and write access to your data set is requirement even if you must copy. And then data security and authentication level is big. So what we are trying to say is like a Kubeflow is also having a feature where is aware of the different types of storage which can be integrated. So starting with the phase one, what you're going to do. So first thing you're going to do with exploration. And now when you do the exploration phase, how can you do that? So there is one tool which is called Jupyter Notebook, which we know. Using that, you can do the explorations. Starting point of data exploration, started via launcher, means you will have a buttons and all. And then this notebook, basically, let me tell you, Jupyter Notebook, you can run independently also. And you can run on Kubeflow also. So run behind ambassador proxy and started via Jupyter Hub. So this notebook is been started using Jupyter Hub, and this is one of your database, a data analysis tool, which can help you to exploring the data. And then data typical volume types are used, which is shared home, shared libraries, training data, shard notebooks, and models. So yeah, so Jupyter Notebook, you can do all this exploration work. You can write a code, you can run the code, you can see the some of the you know workflows and all stuff like that. So you can do that very well. So this is the one phase one. Then it is coming for the training phase. So training phase, you need a ML framework. So PyChart is one of the important one, but we have TensorFlow also. So multi-machine training can be started via a call from notebook or externally via job. Many possible training types are available. Security mappings and volumes which require training code, share libraries model, and training data and logs. So this all training phase can be done on the through the code, share libraries, models, training data, and logs. And again, you have a Kubeflow, you have a multiple training things. Now this is the serving. So serving primarily there's one feature which is built in, which is called KFServing. This is the KFServing which is named as the KFServing now. Long-term KFServing simplified story. So that means this is a new name for this. Now KFServing, which is coming from the Knative, powered by Knative. But apart from that, there are so many servings are there. Some of them are like TensorFlow serving has their own serving. Batch, Seldon, NVIDIA, TensorRT, Istio, and few more actually. So there are lots of servings are there, but we will use KFServing for this session. Okay, so this is the overall your ecosystems, you can say, for the Kubeflow. So look at it, powered by hardware, and you can run in terms of infrastructure, you can run in your laptop, cloud, private or public, and on top of that you run Kubernetes with Istio, and on top of that you run the Kubeflow, and Kubeflow you will get a lot of utility which I talked about it: pipeline, notebook, dashboard, some training operator, Katib operators, KServe, model registry, Spark operators, and many more. And after that, you can integrate with a hell lot of other tools also. And here you can see lots of integrations are available. Okay, so now what is the workflow? How we work on this Kubeflow? So now let's say if you are a ML engineer, what you will do. So, so if you are a ML engineers, you need some data preparation work, and for that probably you
Yes.
will use Spark operator that you can
Yes.
find again on the Kubeflow. After that, you
Oh,
want to do the exploration work or model development work, coding basically, Python most of the
yes.
time. So then you use the Jupyter notebook. Then you want to, tune your hyperparameter tuning, we call it, that is powered by Katib. You need to remember Katib is basically for tuning the model. Okay, so it should work efficiently. And then there is a Katib also has a model optimization, so you can optimize the model also to make sure that your objectives are match. And after that, the you do the training, model training and fine tuning. And once the model training is done, then you do the serving through the KFserve. Okay, and then here lots of data you have to process, and then some registry you need it also. So here you have a model registry also, model registry which contain the ML metadata and model artifacts. Model artifacts means all the code which is you have trained actually. So this is the model registry. There is one more option which you have is a feast. And feast is a place where you have all the stored, offline feature stored, and online feature stored. So where the data is being generated. So this whole pipeline you see, pipeline downside, which you set up at the Kubeflow pipeline. Pipeline is one feature of the part of the Kubeflow. So you set up all this thing, and this blue arrow you see, it's integrations. That means the moment it is completed, this will start. The moment it is completed, this will start, and then henceforth. So this all has to be integrated and automated. So all these things should be running in the loop.
okay.
Okay, so these are the list of dedicated one if you want to understand that each of this. So there is one integration available, Chainer. So Chainer is one of the integration tool at Kubeflow defined by run deep learning neutral network framework. Also support multi-node distributed deep learning and deep enforcement algorithm. Istio, again, you understand that service mesh is on top of installed on top of Kubernetes. PyTorch, again, it's a ML framework where you have a hell lot of library means algorithm to train your model. Uh, NVIDIA Tensor RT is a serving platform. TensorFlow again is a framework, something similar to PyTorch. Jupyter, that is the place where you can visualize your data and code also. And Katib is again fine tuning, hyperparameter tuning, and all kind of things. This is serving. Questionate is basically a kind of packaging and configuration management deployment tool, you can say, for Kubernetes environment. So Questionate uh, typically we were using earlier before Helm and all. MXNet is a portable ABD scalable deep learning library using multiple front-end languages such as Python and few more. And Seldon is also for the deploying the learning models on Kubernetes. So these are the additional things we have. Now, so look at this Kubeflow. These are the features. If someone will ask you what features you get it, so you can say model registry. Where we store the metadata for the model. You get a central dashboard. I'll show the image of it. It's like one dashboard, just like Jenkins. You had a dashboard, right? Same way. Pipeline you can create. Notebook where you can write a code and explore the data. Then you have a Spark operator for data preparations. Uh, uh, then serving, KServe, Katib again, and then training operators. So these are the tools which we have. These are the things we do in the development phase, and these are the things we do in the production phase. So in a development phase, what will be done? Data preparation, model development, hyperparameter tuning, model optimizations, model training, model fine tuning, and then keep repeating this. After that, we'll make it serving for the production, and then where the users will use, and then keep training, learning, whatever it is. And then you use a lots of store. It's like a play store, right? Yeah, here we have a store where you can get the model store, model all the up-to-date code actually. Okay, so these are the life cycle again, in a same context and so on. Okay, so I'll just skip this
Okay.
customized discussion. Yeah.
Okay.
Where can we install the Kubeflow? So I just said you can install the Kubeflow in laptop also. You can install
Okay.
in the cloud also. Anywhere you can install. But the problem is you can install in the VM also. But the problem is
Uh-huh.
you need a Kubernetes. Yes. So wherever you
Okay.
have a Kubernetes, you can install a Kubeflow simple. That because Kubernetes is a platform needed for Kubeflow. So Kubeflow, Kubernetes though, because you used to install in laptop also, cloud also, private cloud, public cloud, bare metal also. So that means Kubeflow you can install anywhere. And so yeah, so first what you need to do, you need to create a Kubernetes environment. Okay, Kubernetes
Okay.
clusters.
Uh-huh.
Uh, Probably I'll create in a laptop
Mini
or
cube. Uh-huh.
maybe
Okay.
uh, yeah, Minikube or maybe AWS. I'll check that I have a limited resources in laptop. So I'll check
Uh-huh.
if it is running. If it is failing, then I'll go for the AWS. Okay. After this, once you're done, then you have to install the Kubeflow. So Kubeflow you can install through the customize options. Few more options are there. You can install through customize. And after that, you will have to create a resources. Okay. So yeah, you can install in a multi-platforms, Windows, Mac, Linux, all these places you can install. Now, here if you see that minimum requirement for RAM is 8 GB, 4 CPU, and 40 GB. So this is the requirement for creating the Kubeflow. So please mind it. Okay, so
Oh, okay.
after this, this is the dashboard. Once you install the Kubeflow, this is the dashboard. You will be able to access it. Now, whatever the feature I did discuss, if you remember, first for the data explorations, where is that? So here notebook,
Notebook. Hmm.
yeah. Then tensor board. This is where you can create a some sort of issue management kind of things. So here you can do
Um,
the tensor board. All the storage you have a volumes here. Hyperparameters you have a Katib here. You want to serve for the production, KFServe endpoints are there. You want to automate whole process pipeline, you have it. Tensor board you can find the framework also, and you can also attach to the some contributors and all. So here you see you can create a notebook or create a pipeline, view a pipeline, and so on. So this is something I'll show you. This one, all this, some authentications options are there. That's not so important right now. I know. Now the question is how this Kubeflow is being installed. That is a question. So everything is being installed as an operator. Yes, Kubeflow, or let's say KFServing also, and everything is being installed as an operator. Now the question is what is operator? So I'll put it in very simple way, though offline you can study. Kubernetes operator is a way where you can deploy any resources, any custom resources through YAML, and the specification which you, if you remember, let's say if you want to deploy pod through YAML, then what do you do? Kind is equal to pod, right? Correct now? Kind is equal to pod, something like this.
yes. Yes.
So
Yes.
same way,
Yes.
operator is a basically kind of features in Kubernetes. So when you want to deploy the custom kind, I said custom kind means custom controller. We call it custom controller, but I'm using custom kind just to make you understand easy way. Custom kind, and then this will be deployed in the Kubernetes. So for example, let's say if you want to create a notebook, so something like a kind is equal to notebook, and it will be deployed. That means what I'm trying to say here, Kubeflow has been installed as an operator. Okay, so
Okay.
because it's installed by operator. So now everything has become a kind actually. So let's say there is one operator for TensorFlow, for one for
Okay.
PyTorch, one for Spark, one for everything.
Okay.
So there is a hell lot of
Mhm.
operator has been installed. That means anything you want, just kind this and deploy, and you will get that options. So here it says tend to fall into two categories: create a job that get distributed across the cluster, install upgrade product composed of multiple pieces. So this is something which you can do that through operator. For example, one example here, this is one YAML file, and here you want to create a TensorFlow job. It's like a pipeline, okay? So what you specify, kind is equal to tf job, and deploy. kubectl command, you know that, right? So you deploy. Understood?
Yeah, yeah, got it. Okay.
Yeah. So this kind tf job is not built in Kubernetes. So where it's built in?
Okay.
So this is coming through the operator, which you call it a custom resources. Okay. TF job is not a built-in resources of Kubernetes. It's a custom resources. We call it operators. Okay. So that is how it's been done. Again, you see PyTorch job, there's a kind, different kind. The again, different kind you see. And the specification you will
Got
learn
it.
over the period of time when you want to deploy.
Okay.
See MPI job, chainer job, XBoost job. That means everything deployment so easy with the help of um,
Kubeflow
Kubeflow and operators. Okay,
operators. Okay. Okay.
so that is something which you have to check this. And this, anyways, will set up the cluster and so on. Okay, so yeah, this is your UI. Whichever after installations, you will see the UI like this. And here you see, you create a notebook server. You can create a notebook server, and inside that you can have a multiple notebook. This is the one notebook image. Let me tell you, this is a UI for on
Jupyter.
Kubeflow, but Jupyter UI for the on Kubeflow. But the same
Oh,
Jupyter notebook you can install independently also. It's not like only Kubeflow can do that. No, because earlier we had all this tool. Kubeflow has made it a common platform for all these tools. Remember that. Okay, it's become easy. It's like a website to has created one website where you can get it everything with a click. Simple, but click is much easier. So this is the editor actually where you write your algorithm for data explorations, and then you run. Here you have a run button, you see, and where it will run. So remember that Kubeflow has been installed in the Kubernetes. So there it got run. Now if you see that here, 100 times this should be trained. It will run in 1,000 times in a loop. All this thing coding. This is the coding. Is a separate things. We have to get comfortable a little bit of it. So yeah, training phase, you have so many options available for that. So we do the training, and after that, this is the third feature of Kubeflow pipeline. So you can create a pipeline when you want to automate everything. So this is the UI for just to make you comfortable. I'll show you that anyways after the installations. And once you create a UI, you see that here you graph all this flow. You can see that from the create cluster to analyze to transform to train to predict. All this is coded actually through the pipeline. And some of the SDK architecture is not important right now. This is the Argo flow, Katib job. This is for hyperparameters, serving fetch. These are all the features which you have available, and so on. Seldon. Yeah. So this is your Kubeflow. Did you understand now?
yes, yes. Got it.
Okay. So now in the demo session, what we'll do, we will create one Kubernetes clusters,
Mm-hmm.
and after that, we'll deploy the Kubeflow, and after that, we'll work with the four important component. We'll work with
Note.
notebook. Yeah. Then we'll work with Katib,
Got it.
and
Yeah.
then we'll work with TensorFlow for training the
Mm,
model. The source code I'll
mm.
download from the GitHub. Lots of code, you will find it over there. And then finally, we'll create a pipeline. These are the 4 important
Oh,
features you need to know in order to do the MLOps in a machine learning environment. Got it?
okay. Got it.